Hi class, we're looking at lesson 6.6, which is parallel and perpendicular lines. Before you get started, please do the skills you'll need for lesson 6.6 found at the beginning of the section in your book. Again, you may stop this at any time, pause it, or replay it if you are struggling with any of the information. Let's look at some definitions. Slopes of parallel lines, non-vertical, okay, so they're not vertical, which means they have some type of slope, are parallel if they have the same slope but different y-intercepts. Now, think about that disclaimer. If we have a different y-intercept, if we didn't have a different y-intercept and we have the same slope, that means we have the same y-intercept and therefore it's the same equation. So it's the same line. So in this case, if they have the same slope and different y-intercepts, they're going to be parallel. Now, it's two vertical lines. Think about what a vertical line is. They are also going to be parallel because they have undefined slopes. If you have two slopes that are undefined, then they are parallel as well. What does parallel mean? If you think about parallel lines, they are lines that go on in the same direction at the same slope, and they will never, ever, ever touch one another. Okay, they'll never intersect. So we have two equations here. We have y equals 2/3 x plus 1 and y equals 2/3 x minus 3. Notice in both of the equations they have the same slope. So therefore we can conclude they're parallel. Now, lines that are perpendicular. Now think about what perpendicular means. They're going to intersect. They're going to meet at right angles. So lines that meet at right angles are called perpendicular. We can tell that they're perpendicular because the product of their slopes is -1. So oftentimes we're going to multiply the slope of both of our equations together. If we get a product of -1, we know that they are then perpendicular, which means their lines are going to intersect at right angles. This is why it's so important to understand fractions and how to multiply fractions and whole numbers, because if you see here we have two equations. We have this an equation with a slope of -1/4 and our second equation has a slope of 4. So if we multiply -1/4 times 4, -1/4 times 4, we get a product of -1, which means those lines are perpendicular. Here we've got some definitions. Parallel lines are lines with the same slope but different y-intercepts. Perpendicular lines are lines with slopes that are negative reciprocals of one another. And the product of a number and its negative reciprocal is -1. So we've got two examples here on how to write equations, parallel and perpendicular lines. So we're given some information here. We want to write an equation for a line that goes through this point right here and is parallel to this equation here. Well, the only thing we need this equation for is its slope, and we can throw it out. What is the slope of this equation? If you look, the slope of this equation is going to be 5/2. Okay, that's the slope of this equation. So after we find the slope of this, and we know this, the line is parallel, so it's going to have the same slope, we do not use this equation anymore. Now we have a slope and we have a point. So how do we write an equation? Well, basically we need to find maybe a y-intercept. So we've identified the slope, okay, which I already did up there. And then we could use the point slope formula, okay. Using that formula, we can rearrange everything and distribute, combine like terms, and set it up into slope-intercept form. So we have y equals 5/2 x plus 8. If you didn't want to use the point slope formula, how else could you find that y-intercept? Well, let me just show you a little trick here. Let's move this out of the way. Okay, we could, if we wanted to, remember we've got this point, -2, 3. We have the slope of 5/2, right? And our x is going to be -2 plus b equals, and what's our y? 3. Notice I have y equals mx plus b form here, mx plus b. Okay, this should be a review for you when we studied slope-intercept form. We have a slope and we have a point, and we want to figure out the b. So if we plug in our slope, which is the 5/2, and we have the -2, I'm sorry for the messy handwriting, the smart board's acting up a little bit. We have the -2 for the x value, and we have 3 for the y. Now when we multiply, we get -5 here plus b equals 3. Then to solve this, I add 5 to both sides. And what do I get? I get 8 for my b. Okay, and guess what I had over here? 8 for my b. So that's one way to figure out your y-intercept. And then, again, writing your equation in slope-intercept form. There you go. Important things when you're writing equations. Find the slope, find the y-intercept. That will get you an equation. If you have a slope but you don't have a y-intercept, you can get it either using the point-slope formula, which we did over here, or by using the slope-intercept form, which we did over here, figuring out the b, but then you got to rewrite the equation again into slope-intercept form. All right, let's look at example 2. Moving right along here. Okay, so now we're looking at perpendicular lines. Okay, so the line in the graph represents a street in front of a house. The sidewalk from the front door is perpendicular to the street. Write an equation representing the sidewalk. Seems like we're missing a picture here. I don't know where my picture went in my notebook. It's not in here. Okay, wonder what happened to that. So anyway, so we find the slope of street M. And street M has a slope of -2/3. So now we know that if we have a slope of -2/3, oh, that picture is in your notebook, so make sure you check that out. It's not in my notes here for some reason. Street M, you can see, is a slope of -2/3. So now we find the negative reciprocal of the slope, and that is going to be 3/2. Okay? Since we have the slope now that is 3/2, and we can look at the equation or the graph on the line, we can see that it goes through the y-intercept of -3. Okay? And then we have our equation in slope-intercept form of y equals 3/2 x minus 3. Okay, that's it for the lesson. It's a quick lesson, 2 examples, but the important thing is to always ask yourself, what do I need to write this equation? You're always going to be given enough information. You only need 2 points or a slope and a point, and you can write an equation from that. Okay, you might have to write it into a form you don't necessarily want to have right away, but from there you can always rework the problems. Make sure you're doing the skills you'll need, and we'll be practicing for probably 2 days with these. So take your time, step it out, write things down. Make sure when you find the slope of something, you label it, and then label it perpendicular slope. Symbol for perpendicular is like an upside down T. So if you wanted to find the perpendicular slope, you could also label it perpendicular slope, because here's the regular slope, right, of street M. So just be sure to keep good, accurate notes and be detailed when you're writing your problem so you don't lose any information and you don't forget what you found. Okay? Email me with questions. Have a great night.